Rational numbers. Vocabulary. A rational number can be written as the ratio of two integers. The denominator cannot be equal to 0. Within rational numbers, we have several subsets. We have natural numbers. These are basic counting numbers. Whole numbers include the natural numbers and they include 0. Integers include natural numbers, 0, and all of the negative natural numbers. So we have all of the positive or negative whole numbers and 0. Those are all integers. Rational numbers include integers, whole numbers, natural numbers, and some others. So we have, remember by definition, ratio of two integers, so that means fractions. Fractions can be divided to give us terminating decimals or even repeating decimals. We can change decimals to percentages, so rational numbers can also be written as percentages, and they include negatives. A repeating decimal, the decimal form of a rational number. So if you have the fraction 1/2, you divide 1 divided by 2, and that gives you 0.5000. There's no remainder, so it just keeps going with a bunch of zeros. This is a repeating decimal. These 3 dots means it's called an ellipse, and it means it continues. 2 divided by 5 gives you 0.4 with a bunch of zeros after it. So this again is a repeating decimal. And the same thing here, 5, 6. 5 divided by 6 gives you 0.8 with a bunch of 3s on forever. Now, these are repeating decimals. We can change 0.5000 to just be 0.5 because the zeros don't change the value of the decimal. This would be a terminating decimal. The same thing here. You can drop these zeros to give you just 0.4. However, in the last one, you can't drop the 3s because the 3s are part of the number. 3 will change the value of it. The zeros don't affect it. So this one is only a repeating decimal, not terminating. Changing fractions to decimals. So in example 1, we have 5 divided by 8, 5/8. 5 divided by 8. And you can do long division with Mr. Bring Down. Divide, multiply, subtract, bring down to give you the decimal 0.625. Or you can type it into your calculator, 5 divided by 8. And it will give you 625 thousandths. Example 2. Here we have a mixed number, -1 2/3. Now you can change this mixed number to an improper fraction by saying 3 times 1, which is 3, and add 2, that gives you 5. Now because of this negative out here, we have to keep the negative on the outside. So -5 is our numerator, and 3 was the denominator, it stays the denominator. So to convert mixed number to an improper fraction, that's how you do it. Now we can also divide this using, again, Mr. Bring Down. Divide, multiply, subtract, bring down. 3 goes into 5, and you divide it out, and you get 1.666. Now, if you keep doing this process over and over, you'll keep getting 6s. We can call this a repeating decimal, and we put a bar over the 6 because that's the digit that is repeated. This is a terminating decimal. After the 5, you will only have zeros, so it doesn't change the value of it. Changing decimals to fractions. In example 3, we're given 45 hundredths. This is the tenths place, this is the hundredths place. So we say 45 hundredths. That means the same thing as 45 over 100, or 45 divided by 100. Now you can just reduce this. Both of these are divisible by 5. 5 goes into 45 9 times, 5 goes into 100 20 times. And there's your fraction. For example number 4, we have 0.5 repeating. This is not the same thing as 1/2. That would just be 0.5 without the bar. With the bar, it means 0.55555, and it continues on forever. To change this to a fraction, we look at the number of digits under the bar. There is one number under the bar. So we put 19 in the denominator of the fraction. You drop the bar and everything else and just look at the digit there, it's 5. It goes in the numerator. So 0.5 repeating is 5/9. Example 5, 2 and 1800ths, and the 1800ths part is repeated. So we're going to keep the 2 out front because that's our whole number. 1800ths repeated. There are 2 digits under the bar, so we put 2 nines in the denominator of the fraction. And since the whole 18 is repeated, the whole 18 goes in the top. And we can reduce this. So I know that 18 and 99 are both divisible by 9. 9 goes into 18 2 times. 9 goes into 99 11 times. So 2 and 2/11ths could be an answer. Or you could even change it from a mixed number to an improper fraction. 11 times 2 is 22. Add the numerator, so that gives you 22 plus 2 is 24 over 11. Example 6. Only the 3 is repeating. The 3 is the only digit under the bar. So this one's a little bit different. We have 1 digit under the bar, so we put 1 9 in the bottom. Then you look at the whole thing. Only the 3 is repeated. You subtract the part out that is not repeated. So you're going to say 43 is the whole thing. Subtract the part that's not under the bar, so minus 4. 43 minus 4 is going to go on the top. Well, that is 39. 39 over 9. Well, the bottom has to be bigger than the top. Otherwise, we get a whole number portion, and we really have a number that's smaller than 1. So now we're going to add zeros to the denominator until the denominator is bigger than the numerator. If I add a 0 now, 90 is bigger than 39. And we're done. You could also reduce this by dividing by 3. Let's see, it goes in 13 times, and it goes in 30 times. All right, so this would be your final answer, 13 over 30.